Let's prepare on ILD for Truss. So today we are going to see the ILD for trusses. Okay, so for trusses there will be some difference to be applied. So that only will be getting the ILD diagrams. So here in the objective exams they will be asking the shape of the ILD for a truss. For any member they will be specifying and asking. Okay, so generally this type of questions only will be asked in the exams. So let us take a single example, and with that itself I will be explaining you in all the different terms. That is, in a truss we have top chords, bottom chords, inclined members and vertical members. So 4 different components we have, no? So for these 4 different components, the 4 different concepts has to be applied. Okay, so let us see that all with this single example. So here there is a truss here, and it is having nearly 6 panels, and the points that is at the join, no? So at the top I have mentioned it as U1, U2 to U7, and the bottom it is L1, L2 to L7. Okay, and the height of this truss is H. So first let us see how to find the member, that is ILD for a member that is in the top chords. Top chords means U1, U2 or U3, U4, like this members are there, no? So for that let us see first. So before that, you remember this 2 points. So this is very important. For top chords always it will be compression, and for bottom chords always the ILD will be in tension, and the coordinate for both will be AB by L into H. This is the simple formula. Okay, so first let us see the top chord. So first I have taken U1, U2. So for top chord, the apex should be where, means apex means the height, that is the maximum height of a triangle, no? So that point should be where means it should be in the second letter, that is if the member is A, B means it should be at B. So here it's U1, U2, no? So it should be taking at U2. So here only the apex should be there. So this distance will be A and this distance will be B, and when you multiply the AB by L into H you will be getting like this. That is, I have taken this one as L1 and the other 5 panels are remaining, no? So 5 into L1 divided by the total length, that is 6 into L1 into H will be the height. So you will be getting 5 L1 by 6 H. So that is the ordinate of this member. Okay, that is this ILD diagram. So this will be the ILD diagram for your U1, U2 member. So similarly we can go for the next one, that is now I have taken U4 and U5 member. So if it is U4, U5 means apex should be there in the U5, that is the second element. Okay, so straight to U5 I have drawn here. So as it is a top chord should be always in compression only. So we have to draw the diagram below the line. Okay, so it should be in minus, and the value is similar thing only, 4 into L1 into 2 into L1 by 6 L1 into H. So you will be getting 4 L1 by 3 H as the ordinate of this ILD diagram. So here another important thing is the ILD for U1, U2 will be a mirror image of ILD for U6 and U7. Okay, so if you draw the ILD for U6, U7 means you will be getting like this, and the value here will be same as this, 5L1 by 6H1. And similarly if you take U4, U5 means it will be a mirror image of U3 and U4. So that is what I have written here. So when if they are given any value means and they have asked for the other thing means you can directly answer the value is same only the diagram will be looking like just a mirror image to that. Okay, so this is all about your top chords. So now let us go for the bottom chords. So here I have taken L1, L2. Okay, so this bottom chord L1, L2, and then I have taken L2 and L3. Okay, so if you take in this diagram, if you see here, we know the zero force member concept, no? So when a force is applied here, the horizontal member there will be experiencing zero force only. Okay, if this is the case and they have asked the ILD for the zero force member means then the ILD diagram will be looking like this only. It will be just a straight line here. Okay, so like this only it will be displayed. So this is due to the zero force member L1, L2. So before going into the ILD diagram, just check what are the zero force members that is occurring in that structure. And the next is I have taken for L2, L3, that is the second member. So for this, similar to the same thing, for the previous thing we have done, no? that is 5L1 by 6H. The same thing only will be coming here also, because A, B and LH everything is same. But what is the difference here is, in there we will be taking the apex in the second element. No, here we will be taking in the apex in the first element. That is L1, L2 means in L1 only the apex will be happening. Okay, so here the apex will be like this. So here L2, L3 is given. So in 2 only apex will be there. So in here it's 2. Okay, so at 2 only the apex should be there. Whereas in the top chord you will be taking at 3. Okay, so that is the difference. And another difference is it is tension. Whereas in the top chords you will be taking in compression. Whereas in the bottom chords you will be taking in the tension. Okay, so these two corrections only you have to make. That is compression and tension. And the apex should be coming in the first element in the top chords and second element in the bottom chords. And the formula for ordinate is same only. Now let us go to the vertical members. So here, before going into the vertical member, let us see this. That is, unit load, if it is in the left means it will be tension. That is, ILD diagram will be in tension. When the unit load comes to the right, it will be transformed to compression. Okay, so this you have to keep in mind. And here how we will be calculating means, if you see this diagram, here I have taken U2, L2. Okay, so here U2 is this and L2 is this, U2 is this and L2 is this. So this is your vertical member. Okay, so as I told you before, if it is in the left side, that is the UDL is in left side, means it should be in tension. So here it will be in tension and here it will be in compression. So it means the diagram will be increasing first and then it will be decreasing. Okay, so now you keep this in mind. So now if you see this diagram, it is increasing till the point U2 and then it will be decreasing towards the U3. Okay, so this will be your U2 point and this will be your U3 point, and after that it will be in the compression only. So this is the shape you have to draw for the ILD for this type of vertical members. So here in the above part it will be positive and the below part it will be negative. So here how you should calculate the ordinate means, you have to just take the number of bases. Okay, so 1 divided by 6 here, because it is just one panel and here it is 4 panels covering. Okay, the remaining this one panel, no, that you shouldn't consider. The first panel, that is it's U2. Okay, so from U1 to U2 it is in tension, so that panel alone you should consider, divided by the total panels, so it is 1 by 6. And if in the case of compression, here 4 panels are in compression, that is in complete compression, so 4 divided by the total panels, 6, so 4 by 6 will be your answer here. Okay, so now let us see for the next one, that is U1 L1. So here U1 L1 means it is in the first member. So here U1 L1 means it is in the first member here. So as I told you before, the left side should be tension and the right side should be compression. Here in the left side there is no structure at all. Okay, so from the starting of the ILD itself, the structure will be in compression only. So now if you see, this means it's completely in compression and the number of panels that is in compression is 5 here. So 5 divided by 6 will be the answer here. So only compression, so only right side of that is only taken. Okay, and the third one is U4 L4. So now if you take U4 L4 means it is a zero force member, because as our principle, if this is that is any two lines are crossing like this and a vertical member is there, means it will be in a zero force only. Okay, in this case you should apply the load and see. Okay, so there are two types of structures in truss. One is through type and the another one is deck type. Okay, so through type means the truss will be above the supports. Deck type means the supports will be like this. The supports will be like this and the truss will be bottom, that is below that support. So this will be your deck type. Okay, so here this is a through type, so you should apply the unit load in the bottom chord. Okay, so that is the rule. So you will be applying the unit load like this. So when you apply like this, the load will be transformed to the inclined members only. So this concept we have already seen in the zero force member concepts, no? So this member definitely won't have the load. Okay, so this is definitely a zero force member when the unit load is applied there also. Okay, so if this is the case, means you can draw a straight line for that member. That is, the ILD line will be a straight line for this member U4L4. But when the case is a through type, means it will be differing. So that also I will be telling you. The next thing we are going to see is the inclined members. Okay, so now we have finished top chords, bottom chords and vertical members. So next is the inclined member. So now we are going to see U2 L3 and U1 L2. Okay, so these two members we will be seeing now. So here the concept is just reverse to that of the vertical member. Okay, in the vertical we just saw now, when the load is left it is tension. Here when it is left it is compression, and when it is right it is tension. Okay, and then you have to multiply the ordinate with cosecant theta. Cosecant theta means it's nothing but the 1 by sin theta. So it will be opposite hypotenuse side by your opposite side. So we can take the angles like that, or we can take the values like that. Okay, so here I have taken U2 L3 here. So as we saw here, the left side should be in compression. So till U2 it should be in compression, and after U3 it should be tension. Okay, so after U3 it should be tension. So it will be joining like this, and the ordinate is similar to that only. Here only one part is covered, so 1 by the total length 1 by 6 into cosecant theta, and in the top if you see means it is 4 parts, so 4 by 6 into cosecant theta. Okay, so cosecant theta means it's nothing but you have to take the angle here. So if this is your inclined member, if this is your inclined member that you are taking, here you should take the angle theta. So you will be getting cosecant theta as hypotenuse side by your opposite side. So if this hypotenuse side is 5 meter and this is 4 meter, means you should just apply 5 by 4 like that. So you will be getting the value. Okay, the next is U1 L2. So U1 L2 means it is your first member. So in the first member, left side of that element we don't have any structure. So the right side only is having in the structure. So obviously it will be only tension. So from U1 to this U2 you will be getting this tension, and then you will be getting the tension only. So it will be a positive sign, and the answer, that is the ordinate, will be 5 by 6 cosecant theta. I hope you have understood the concept of all the top chords, bottom chords, vertical member and inclined member. So if you feel some difficulty with the lecture, means just download the PDF in the description and see it once, because the whole thing will be in a single paper, so that you can connect it easily to the truss and study that. I think you will be understanding then. Okay, so now let us see the two examples. So here example is given. So this is a truss of having 6 panels, 6 cross 6 into 36 meters. So total span is 36 meter and the height is 6 meter. So what is the ordinate of member AB? So this is the ordinate. Okay, so here AB, it is the bottom chord member. So bottom chord means the structure, that is the ILD, should be a tension member. Okay, I have just reversed it and drawn here. So actually the diagram should be like this only, or if you draw like this, means you should mention here as positive. Okay, so that mistake alone I have done here, just correct that. So it should be a positive one because it is in tension, and then the other things are same only. So when it is a bottom chord, the apex should be in the first element, that is at A. So direct to the A, you should draw the apex here, and the ordinate of the apex is AB into AB divided by L into H. So A is having 2 panels here and B is having 4 panels here. So 2 into 6, it is 12, 4 into 6, 24. Total span is 36 and height is 6. So the answer is 1.33. So this is the ordinate of the member AB. So this question number 2. So as I told you before, there is a deck type truss. So this is your deck type truss. Below the supports you will be having the truss. So similar bridges and all, you'll be seeing the bridge will be going, and below the bridge the truss will be there. So that type of truss is only called as deck truss. So when this is the case, you cannot take this member as a zero force member. This member as a zero force member, because when the deck type structure is taken, the unit load should be applied on the top. So when this unit load is applied here, this member will be taking a unit load of 1. That is, the unit load will be taken by that member. It cannot act as a 0 member at that point. Okay, so if this is the case, means you can't take that as a 0 force member and you have to draw the ILD for that diagram. You cannot draw a straight line. Okay, so this is apart from this question. So in this question they have just asked the ILD for AB. So this is the vertical member here. So they have asked the ILD for that. So as we know, for a vertical member, the left side the load should be taken as the tension and the right side it should be taken as a compression. So it should be like this and then going like this and going like this. So let us, a positive should be coming first and then a negative. So this is a general diagram. So now let us see the options. Okay, in the first structure only tension is there, so obviously this won't be a right answer. In the second structure, if you see, means only tension is there, and the third, that is from compression it has moved and then the tension has come. In the third structure also tension and compression both is there. In the fourth structure only compression is there, so this also will be a wrong answer only. So when you look into second and third option, any one is only going to be a right answer. Okay, so before AB there is a tension and after that it should meet the compression. That is the case here. But in the option C, if you see, means AB is in compression. This cannot happen at all. Okay, so that also should be a wrong answer. Here only option 2 is the right answer. So you may think why it doesn't fall here and go like that. Okay, so it depends on the structure. In this structure, this is your ILD. In the previous example we saw, no, that is the theory part. In that, if you see, means the first vertical member, that is U1, L1 will also be having the same type of structure for ILD only. Here also this is the first vertical member, but as this is in the deck type model, it may look different to you. So that only will be assuming like this, but actually this is your first vertical member, so the ILD will be like this only. So this is the answer here. Thank you and keep watching for the next lecture on arches and cables.